Because now what I'm going to do is I'm going to do the work on my desk. It's a little easier to see and video-wise if I do the work on my desk. So let me get this situated here, and everyone should be able to see that. Well, let me turn the light off. All right, now I need to brighten this up. Too bright. All right. You at least have a copy at home. You should be able to follow along with this here. So number one, it says, calculate the distance a plane flies on a 6.5-hour flight from Chicago to the Bahamas. Assume a constant speed of 600 miles an hour. All right. So whenever you're doing problems like this, first thing is I always like to write out the formula. So again, in this particular question, what are we solving for? Okay. Well, we're not solving for constant speed. We're calculating the distance, right? First thing is, let's go back to just the formula for speed itself. What is that? Can we tell me? Very good. Distance divided by time. So I'm going to use S. Oftentimes you'll see as we go along here that the speed of an object, whether it is speed or velocity, oftentimes uses the variable v. But for our simple purposes, we'll just use S. So we said distance over time, right? So can you all see that up there? Okay. But going back to this problem, what are we actually, there we go, solving for? Distance, right? But is our formula set up for us to do that? We got to do a little rearranging of this formula. So we got to bust out the old algebraic concepts here. So I need to get distance right here by itself. So what do I need to do? I need to get that time out of there, don't I? Could you say a little louder?
Multiply both sides by time.
You got it. We're going to multiply both sides by time, because when you do that, these cancel out. Remember, what you do to one side, you got to do to the other. So now, and I'm the type of person, you may not care, but I'm the type of person who likes to have what I'm solving for on the left-hand side. So don't freak out when I switch it around. It's all the same. It's just I prefer my unknown, what I'm solving for on the left-hand side. So that means I got distance set up to solve for distance. But now I've got speed multiplied by time. So once I've got this formula all situated how I should, then I like to go ahead and plug in my numbers that I know. Again, my speed was 600 miles per hour. Again, that line just means per. Okay, I could have written it mph, but since we are dealing with math, I put that little line there. Multiplied by time, which was 6.5 hours. Okay. Now, what can I do with my hours units here? I can cancel them out because I can cross cancel, right? Leaving me with, I guess I could put MI there. Miles as my unit, which is appropriate for distance. And so now my distance traveled was how far? 2,100? 2,100 miles. And that's your answer. Oftentimes, I like to have my students circle their answers. I don't take off if you don't. I just like to have them circle their answers, especially when we start getting all this work done right here. And then it just kind of makes it a little easier for me to decipher what you want me to look at as your answer. Okay? Questions on number 1? Let's go on to number 2. Number 2 says, determine a skier's speed in meters per second if it takes her 95 seconds to ski down a 1,670 meter slope. Okay. So what are we solving for in this one? Speed. Very good. So, again, going back to the equation, speed equals distance divided by time. That is a t there. Do I need to do any rearranging of the formula to solve? No, I do not. So, once I've determined that I don't need to switch it around, I go ahead and just plug in what I know. Okay, excuse me. So we have the fact that it takes this individual 95 seconds. So does that go on top or bottom? Bottom, okay. 95s. And the individual is going down a slope that is a distance of 1,670 meters. Now, looking at the units here of distance and time, are those the appropriate units to solve for speed in this case? Who says no? Who says yes? Bailey, why do you say yes? Exactly. In the question itself, it says meters per second, okay, to solve for meters per second. It's really important that you read a question more than once so you can identify, A, what you are actually calculating, and B, is there a specific way that they want you to answer it in, okay? Because there might be sometimes down the road, whether in the near future or the further future, where you might be given units in one form, and you got to answer it in a different form. We're not there yet, but there will be a time where we will be doing that. All right, so after you calculate this, distance divided by time, what is the overall speed of this individual? Yes. 17.6 meters per second. That's scooting pretty good. Okay. That means for every second, the skier is going the length of 17 and a half of these. That person's scooting pretty good. If we wanted to, we could switch that over to miles per hour. But again, that's for another day. Questions on number 2? All right. Number 3. Let's see if I can. There we go. How much time does it take for a student running an average speed of 5 meters per second to cover a distance of 2,500 meters? Okay. So like before, I'm just going to go ahead. S equals distance divided by time. What are we solving for, number 3? Time. Okay, so time right here, we have to get that out of the denominator. We gotta we gotta isolate it. We gotta get it out of the denominator and by itself. So this one might take a couple of steps. Okay. What's the first step we need to do? We did it before. Yep. Multiply both sides by time. Okay. That allows for those times to cancel. And now we get distance is equal to S times T. Do we have time by itself yet? No. What do we have to do? Exactly. Divide S, right? Divide S on both sides. which allows those S's to cancel. And now we get time is equal to distance divided by speed. And so once we've got that set up, we can take our known values. Our distance was 2,500 meters and a speed of 5 meters per second. So as you write this out, and also as you look at it on the board, for our 5 meters per second, that's our denominator, right? But look what we have here. We have meters per second in a denominator. So that second unit is a second denominator in a denominator. We really can't have that. And I'm just pointing this out to you so you kind of get an idea for when we solve for time in a situation like this, why we get the unit of seconds that we do. So we can't have that down there, that unit of second, that second denominator. So we're going to basically remove it and move it up here to where you get seconds over number 1. Okay, I know it's a weird thing to do or to see, but you can't have a denominator typically in a denominator. So it just gets the royal treatment and gets moved up here. And so now, when those meters cancel out, look what's left as a unit. Seconds on top. So to solve this, what do we get? 2,500 divided by 5? 500 seconds. But going back to this whole idea, you don't have to necessarily worry about that. I'm just showing you kind of where it came from. As far as you need to know, time will be in seconds. Okay? Yes?
Will there ever become a problem if we just like canceled out the meters, since the meters is on top? Could I just like cancel them out since there's meters on top here and bottom?
I mean, you could. And eventually, the more you do these types of problems, like conversions or what we say, like the dimensional analysis types of problems, when we get there, you're going to learn you might have a slightly different way that you want to solve, that you feel comfortable solving problems. And that's perfectly fine. If as long as you're showing your work and everything's logical and you are coming up with the right answers, by all means, do what works for you. Okay. All right, just a couple more here, folks, and then I'm going to let you loose on your homework. Number 4, find the speed in meters per second of a swimmer who swims 110 meters towards the shore in 72 seconds. So I think by now you are probably pretty good at determining the formula that we use, but also what we're solving for. Again, what are we solving for in number 4? Speed, okay? And what units should we have in the final answer? Meters per second. And looking at the values that you've been given, does it appear that we're going to be good on that end? Yeah, okay? So speed is equal to distance, which is 110 meters, divided by the time it took of 72 seconds. So what was the speed of this swimmer here? And what's the unit? Very good. Meters per second. Now, as I just asked, I go, what's the label? What's the units on your answer? Okay. I am a stickler for labeling your answers when needed. Okay. Because if I just asked this question, you replied with 1.5. 1.5 what? 1.5 bananas? See, I mean, it could be 1.5 bananas, but probably wouldn't be appropriate for this particular question. So you got to label your answers when appropriate. Okay? And typically, anytime you do a math question, there's going to be some sort of label. All right, that's number 4. Last one here is number 5. Okay. Number 5. Find the time that it takes for a thrown baseball to travel to first base if it is thrown by the third baseman from 38 meters away at a speed of 22 meters per second. All right. So again, I always do this. Now, when it comes to you, you don't have to do this, writing the initial formula every single time. I just do it just so, A, you can see where we come from, and B, in my head, I've got all the appropriate variables out there. I'm not missing anything, okay? So, what are we solving for in this particular question? Time, okay? So now, I'm not going to show the steps. We've already seen the steps. What will be the formula to solve for time? Yes.
T is equal to 38 meters divided by 22 meters per second.
Okay. So in terms of variables, it's going to be distance divided by speed.
Oh, yeah.
Okay. So once you've got that, and what did you say our distance was?
38 meters.
Okay. Our speed?
22 meters per second.
And we know, again, I'm not going to show you again about the whole seconds unit moving. So what do we get? How long does it take for this particular ball to travel? Anybody? 1.7 seconds. Very good. Questions on speed. Now, I'm going to kind of add on to this 5th question here. Instead of speed, I asked you to calculate velocity. Okay? A, should our speed of the baseball change any? No, you'll still have the 1.7 seconds, but how would your answer differ? Very good. And so how would you describe the direction of this baseball? Ms. Johns, how would you describe the direction of this baseball? Oftentimes, the question itself will give you some hints. So if you look back at number 5, you see anything maybe in the first line?
Time.
Yeah, we solve for time. Okay. Now describe the direction in which the ball might have been traveling.
It's going away.
It's going away, but there's a specific location where it's going. To first base, or towards first base, exactly. So if you wrote down, again, this is if I asked for velocity, you could write down 1.7 seconds towards first base. Okay? And you can do that whether you solve for velocity itself or if you solve for distance. Okay? Just pay attention to what is being asked, okay, whether it's speed or velocity. Questions? All right, I'm going to end this recording. I'm going to post those for the remote and B groups. And somewhere, there it is. I'm going to start.